Alright, more practice with some exponential equations. In this case, we have bases of 9 and 27. So we have to think to ourselves, what can be the common base? Always try to see if your smaller base is your common base. In this case, 9 squared is 81, so I cannot express 27 with the base of 9. And that's my cue that I have to change both bases. So what base can I express to become 9 and 27? And in this case, the common base is 3, because 3 squared is 9. Do not forget to rewrite your other exponent. And 3 to the third is 27. Do not forget to rewrite your other exponents. Let's distribute the 2. And let's multiply the exponents there. So, now that we have the bases are the same, let's cross them out and set the exponents equal. And then finally, subtract 2x, giving you 2 equals x. So now, that's just revealing the skills that we learned yesterday, in which we had to change both bases. All of the exponential equations we've worked on thus far have had integer bases. Here's an example that we do not have an integer base. In this case, we have a fractional base. So how can we find a common base if this is a fraction? In other words, how can I substitute for 8 to have a base of 1/4? Well, I can't. So I can manipulate 1/4 though. And I can express that as 4 to the negative first power. So the story here is that if you're working with the fractional base, express that as an integer with the negative exponent. Now we have a new resulting equation, which 4 to negative x equals 8 to the 1 minus x. And now we can more easily substitute for 4 and 8. So let's see if 4 is our common base. 4 squared is 16. Nope, I cannot express 8 with a base of 4. But I can express both of these bases with a base of 2. I know that 2 squared is 4. Don't forget to rewrite your old exponent. And I know that 2 to the third is 8. Remember that you're substituting for these bases with an equivalent base. Don't forget to rewrite your other exponent. So 2 times negative x is negative 2x. And 3 times 1 minus x is 3 minus 3x. Don't forget, you're distributing there. We're out of room, so let's set these exponents equal after crossing out our bases. Therefore, we have negative 2x equals 3 minus 3x. Let's add 3x to both sides, giving you x equals 3. So, here's an example in which there's no exponent over here. Well, if there's no exponent written, the exponent's 1. So now we have to think to ourselves, what can be our common base? Well, 25 can't be our common base because 25 squared is 625, I think. That's not 125. So we have to use 5 as our common base. 5 to the third is 125. Don't forget that old exponent. And 5 squared is 25. The old exponent is 1, so I don't need to include that. I can if I want. So now we have 5 to the 3x equals 5 squared. Cross out the 5's because they're the same, and set the exponents equal. 3x equals 2. Divide by 3, and x equals 2 over 3. So now the original equation was 125 to the x equals 25. So that's saying that 125 to the 2/3 power should be equal to 25. And we could check that. Power over root. The third root of 125 is 5, leaving us with a power of 2. 5 squared is 25.